Good evening. My name is Jackie Adjacola, and I'm a senior manager here at Wallis Annenberg PetSpace, and this is my friend Janie. Yes. For the launch of our Animal Matters lecture series, we are very fortunate to have with us tonight world-renowned scholars from a variety of fields, all relating to the human-animal bond, like the one we have with Janie. Yes. We have here Gregor Larson, the Director of Paleogenomics and Bioarchaeology from Oxford University in the UK. Also, Naomi Sykes, who is the Director of the Humane Lab at the University of Nottingham. And finally, Dr. Eric Strauss, our neighbor from Loyola Marymount University. He is the President's Professor in Biology and the Executive Director of the Center for Urban Resilience. And we are pleased to work with them as Annenberg PetSpace Leadership Institute Fellows and part of the planning team which helps envision and plan the programming within our space. So please help me in welcoming first up to the mic, Gregor Larson.
Hello. Good evening, everyone, and thank you very much for coming. I wanted to start by saying that when I was in 8th grade, I took a practice SAT test. I don't know why this was. And I got to the antonym part or the synonym part or whatever it was, and there was a word, and it was August. And I thought, there was a whole bunch of words next to it, and I thought that was a month. And then it took me a while. It was only years later that I realized that it was actually August. And that it had another meaning. I was like, okay. And so what's nice about this evening is that it's a real pleasure to be amongst the first people to speak at this incredible place. And I feel like I am very much amongst an august group of colleagues who are, the three of us are giving a talk tonight, and an august audience. And so and even though we're in September, which is not August, but so I wanted to start this evening, oops, there we go. I wanted to start this evening by telling you a story about when I lived in Azerbaijan. I was there working for an environmental consultancy for a couple of years. And I had learned to speak Russian a few years before that. And every time I got into a taxi, which very much like these Zhigulis, which looked very similar to this, and I would get in the cab, and every time I got the same 3 questions from the cab drivers. And they would start by saying, so where are you from? And it just started to occur to me that our interest in origins is it's universal, and everybody wants to know something about you. And the first thing they want to know is, where are you from? And so I would say, well, okay, you know what, I'm from the US. And more than once, I got stopped by taxi drivers like, no, where are you from? I was like, well, what do you mean I'm from? They're like, no, anybody can be from the US. It's meaningless. Where are you from? As if though being in the US meant because my ancestors could have been from anywhere else, that where I was from depended on where they came from to get to the US, because nobody in the US is actually from the US. And I just thought this was kind of curious, because where are you from was a question about your ultimate origins, and somehow that was meaningful in how that determined who you were, and that gave them a deeper insight into who you were. And so what I've been investigating over the last 15 years or so is the origins of a lot of different domestic animals, because ultimately I'm trying to ask these same thing of the animals. Where are you from? Because that's going to be meaningful to me in terms of where they come from, and that's going to tell me more about them. So just as a, for instance, you, sir, where are you from?
Well, then judging from what you say, I guess I would have to say Great Britain and Lithuania.
Right. So my joke here was going to be, I went to high school in Lithuania, but nobody's going to believe that. But if I had gone to high school in Lithuania, then you and I would have had a connection. And we would have said, wow, and did you go to Vilnius? Yes, I was in Vilnius, right? So actually, I have a cleaner from Lithuania. Anyway, so she's just left. But the point is that somehow when we know where someone else is from, we don't care anything else about them, but that's the first question we ask, because that is then telling us something that's more deep-seated about themselves, regardless of what music they like or what food they like or anything else. Where they're from tells us something important. So we think of this so much about our own selves that we're so determined to find out more about ourselves and where we're from. This is an output from a popular company where you can send a cheek swab to, and you send them your DNA, and then they run a big DNA analysis, and they send you back an analysis like this, which says that you are 21.2% Southeast Asian, which is equal parts fascinating and completely meaningless. Right? What are you going to do with that information? How does that help you understand who you are? And yet somehow we want to know whether that's 21.2% or 21.1%, because we interpret that in a way which means this is where we're from. And interestingly, this is where we're from everywhere. Everyone is. You go back 10 generations and you have well over 512 direct ancestors. So where are they from? Which means where, I guess gets confusing, very hurt. But it doesn't stop us from asking these questions the whole time. And it's the same thing. Yeah, easy, isn't it? Like, just pull it off of. So, but you ask the dog, and you say, "Where are you from?" And they look at you like this. They don't even know. You can't ask them directly because they have no clue where they're from. But that's part of what we're trying to get at here. And if it's true now for your dog, there's another popular company where you take a cheek swab of your dog, and you say, "Where's my dog from?" And instead of saying where it's from, they tell you what it is. Which is, again, a 24.7% Labrador Retriever, ultimately interesting but meaningless as well. I mean, Anyway, that's a friend of mine's company, by the way. They're doing some really cool stuff. So what do? In our lab, we take a slightly different approach because what we figure is that if you just look at the modern population alone and try and map that population directly onto the past, that you're going to make a series of mistakes by assuming that there is an analog that we can use the past or use the present to look at the past. And what we're realizing is that there is so much dynamism and so much change and so much flux in the past that if you just look at that outer layer of the onion, that very thin, gossamer, tiny little aspect of what is now, that bears no relationship to what's in the past. So what we do in order to make inference about the past is we say, let's dispense with the modern stuff and guess at it. Let's look directly at it. So we take a bunch of bones. This is not a very large dog, as Naomi would tell us. This is a cow, or bits of cow anyway. And we grind up the bone, and we get the DNA from it, and we throw it on fancy machines that go ping, and those machines spit out results, and then we can directly assess what was happening. So rather than trying to guess the whole film, we just watch the movie. And so the more bones that we get from different times and different places, the more we can actually look directly at the past while ignoring everything about trying to infer the past from the present. So this is an example of the kind of thing that we do. This is a tree. So you can see up there in black, there was a dog that we got a couple years ago from Ireland, from a site called Newgrange, that was about 5,000 years old. So this is a dog that was just kind of tossed into a pit and about 5,000 years ago, and we were able to sequence its entire genome because we got a very small bone out of its inner ear called the petrous bone. It had phenomenal DNA in it. And then we could get that genome and compare it against everything else on this, which are modern dogs, some breed dogs, some village dogs, some other kinds of dogs. And we built a big phylogenetic tree, which told us about the relationships between all these dogs, who was more closely related to whom. And when my postdoc at the time came to me and showed me this tree, I immediately looked at it and was like, my God, what is that? What is going on there? This is insane. What this is demonstrating is that we have a very, very deep split that is supported very well, that's dividing this tree into two halves. On one half, we have this grouping here, which seems to represent, or seems geographically to represent all sorts of dogs from Western Eurasia, more like what I would say Europe or sort of the Levant in that area. And you can see that that split must be deeper than 5,000 years because our 5,000-year-old dog is all the way at the tip on that end at the top. So that means the split must have occurred before that. And on the bottom, what we have is everything in red here, and this all seems to be East Asia, or at least kind of East Asia generally. And then when we plot all of those dogs onto a map, we end up with something like this, which we thought was really kind of crazy because what we have then is, it didn't have to be on the tree. You could have things from everywhere represented on the tree in a deep split, but in our case, what we had was a very big geographical split, splitting out dogs, a lot of village dogs in the east from a lot of dogs in the west, and they were very distinct genetically at the deep genome level. Which then that started to make us rather curious, because if it has to be older than 5,000 years, and what the analysis we ran suggested that it was actually maybe more like 10 or 11,000 years, then if you have a split that's that deep temporally, and we have no real archaeological evidence of dogs moving across this space at about that time, might that suggest that actually all dogs globally are coming not from a single wolf population, but might be coming from two wolf populations? So I am a geneticist, and as a geneticist, my role is to be hyper arrogant relative to the archaeologists. I have to, it's in my best interest to presume that no one has ever worked on this in the past using any other form of information and dispense with all of that and just go, well, genetics takes precedence over everything else. And of course, my lab then said to me, well, maybe we should start to look at the archaeology. And well, yeah, so we started to do that as well. And what we found was there's a whole bunch of things like this. Actually, kind of looks 3D, doesn't it? It's kind of cool. And so this is a dog burial. This is an Iron Age dog burial from Thailand. And you can see this dog was placed in the ground with great care. It wasn't just thrown down a well. It's a full skeleton, so it wasn't just bits and pieces of the whole thing. And you can see right in the middle there's a bowl on which is being placed. Maybe it ate out of this bowl. Maybe this bowl was inscribed with something about the dog. The point was, this is a dog that mattered a lot to the people who knew it and owned it during its lifetime, and then it was buried with a great deal of respect. And we find things like this all over the world. These are in Japan, southern Scandinavia, even here in the US. There's a dog burial similar to this 10,000 years ago in Illinois, in the site of Custer. In Canada, this is de rigueur. This is how things work. And even if they're not being buried specifically, we find dog remains all over the place. So we can date those dog remains and then start to look at that pattern globally. And what we found was that by dating them and putting those on a map, everything in the lighter color, so the yellow to red, are older dog remains that we can find that are directly radiocarbon dated. And then as we get more into the blue colors, they are more recent. And again, what we start to find, and this is really pretty interesting, is that quite a few dogs in the east and quite a few dogs in the west are old, but everything in the middle is really quite young. And we finished there at 8,000, but a lot of those are much more recent than that, which again seems to suggest we have genetic evidence, which of course takes precedent. Oh, and then the archaeological evidence comes to support us, that we might be talking about two separate origins for dogs from two independent populations of wolves that subsequently met and mixed and created the kind of global dog population that we know of today. Now, I should stress that this is still a hypothesis, that we are in the process right this very moment of testing this. And one way we can test this is by looking at dogs, looking at the genetics of dogs that are much older than that Newgrange dog, which is about 5,000. So we've got a series of dogs that are between 8 and 10,000 years old that we're also trying to get big genomes for to see what the pattern was in the process. Because what we suspect is after these two origins, that dogs were moving around with people and then may have interbred in a way that confused and conflated all these different genomes, making it very difficult for us to really say whether or not there was one origin or two origins or possibly more. So when we start, and that's been part of the problem, is that because of all of this admixture, what we call, or all of this mixing between these different populations, that's confused everything and made it all very difficult to say, well, what's coming from where? So we start looking at a different part of the genetics, which we call the mitochondrial genome, which is much smaller, much easier to look at, but is only a single locus. So it's limited in what you can say from it, but we get a lot more samples. And so you trade bigger sample size for the relative amount of resolution that you can get. And in this particular case, what we found was that in Western Europe, between about, say, 15,000 years ago to about 3,000 years ago, most of Western Europe was dominated by this tan orangey color. But then after about 3,000 years ago, we look at, and all the way up to the present, it's dominated by the darker gray color. And we've run some modeling on this to say, could this have happened just as a process of evolution so that you get different changes in the population? Or is this more to do with a population replacement? You had a population in situ in Europe and another population came in and turned the whole thing over. And that looks a hell of a lot more likely than the other option. But what is the timing of this? Where are these dogs coming from? And what's happening to that original population that was possibly in Europe before you had something coming in from somewhere else? And what does that mean generally about the way in which we operate as human beings with our domestic animals, and how much have we done as people to move everything all over the place, thus blending all these animals together and making it therefore impossible to infer the past from the present? So what we did is we decided to take a slightly different approach with this, which is really pretty simple in concept, but sort of it took us a while to get there. So it's one of those eureka moments where you go, actually, why don't we just make it as simple as possible? Oh yeah, let's try that. So the way I like to demonstrate is with M&Ms that you can tell I acquired around Easter, hence the pastels. It's when I was thinking about this. And what we thought we would do is try and correlate the genetic distance between any two samples in our data set with the geographical distance of where those samples came from. So what you can see here is that if we assume that the colors are genetics and the location on the table is the geographic distance, then any two light blue M&Ms, which genetically are very close together, are also geographically very close together. And anything that's very far apart, say the yellow to the light blue, those are very far apart genetically because they're different colors, representing different amounts of difference in their genome, and geographically really quite distant as well. So if you have a very strong correlation between short distance, short geographic and short genetic distance, long genetic and long geographic distance, then your R value, the correlation value, is about 1. So the more different you get, it's about 1. The other possibility is that if you were to take this, if humans were to come along and end up associating with these animals in something like a domesticated context and start moving them around between places, as we know humans are wont to do, we end up with something like this, where everything is all mixed up and blended. So you just take something from somewhere and you take it somewhere else, and then what you end up with is a bunch of M&Ms of a bunch of different colors, and now there is no correlation between your genetic distance and geographic distance, because right next door to each other you could have two dogs that bear no genetic distance, genetic correlation with them whatsoever, and that, in that case, the R is about 0. So you can have that 1 is your peak, 0 is nothing, and you can see how blended the whole thing gets. And what we decided to do was start to look at this in a variety of different wild and domestic animals. So 2 PhD students of mine grabbed a ton of samples that were publicly available, plus some that we generated in-house. And we first looked at wild boar, and the wild boar correlation you can see is about 0.7. And what we know from other studies that we've done is that wild boar tend to have very good geographic structuring. Samples from India look very different from samples in Turkey, look very different from samples in Taiwan, which are very different from European ones. And they tend to be very geographically restricted. So 0.7 makes sense then. It seems like everything is nicely geographically partitioned by its genetics. But then we look at domestic pigs, and again, thousands of these all the way across the old world, and we find that that just plummets all the way down to about 0.25 or something. And what we think is that this is a very nice proxy, a very nice signal of people relating with wild boar in a particular way that leads to a domestic animal, and then marching across the landscape carrying their domestic animals with them, and then that reduces the correlation between the genetics and the geography, and therefore we can see a giant signal of this movement by just comparing that single number. So then we thought, okay, well, let's look at wolves. Wolves, we know, are the progenitor of domestic dogs, and in wolves, maybe not quite as good as wild boar, but still wolves are very good at geographically partitioning themselves, and we get a value of about 0.5, still pretty good. And then we said, okay, well, let's look at the dogs, and as you may know, dogs get moved around quite a bit, and it drops all the way down to 0.02. It's about as close to 0 as you can get. In fact, I think the confidence intervals drop below 0 there, which is meaningless, of course, but that's kind of half the point, is that we have mixed up dogs to such a crazy degree all over the place that now the dogs bear no genetic or geographic correlation in line with what we know that their wild ancestor is. And so then we say, well, that's the modern picture in both cases. What might that look like if we did it through time? If we did a sliding window where we started back 9,000 or 10,000 years ago and came all the way forward, would we be able to see a signature of people moving dogs around in times when they moved them around more regularly or when they didn't move them at all? And so this was just the data set we were playing with. We got ancient samples from 3 different areas of the world, and geographically and temporally not terribly uniform, but enough of the samples that we had at the time. And then we did this sliding window approach to measure that value of R. So this is 0.02. This is modern dogs, and you might think, well, modern dogs are 0.02 now, wolves were 0.5, might it just go from 0.5 down to 0, and just a nice steady climb because we've got domestic dogs and they start moving around, or maybe it's a very recent thing when it comes down to 0, and we run the analysis and it looks like that. And it's insane. It's absolutely crazy because even though we have very few samples and not a whole lot of sequence information here, we can pick up, the confidence intervals are not super tight, but we can start to pick up these major times when people are moving things around. And the first one that jumped out at me when I looked at this, I said, wow, what on earth is that? That is, I mean, look at the steep drop there, where we're going again from about what the wolves are, and it's interesting the dogs start out about what the wolves are now, about 0.5, and it drops all the way down to 0, and you can see it match perfectly in line with about 7,500 years before now, 7,500 years ago. Well, what happened 7,500 years ago? And given our data set, it's not too much of a surprise when you know that farming develops in Anatolia, and then about 7,500 years ago, people start bringing in their farming ways of life, including their domestic plants, their domestic animals, and a whole lot of material culture, including dogs, with them into Europe. And by doing so, there are dogs already in Europe, and that means the one they're bringing in from the Near East start to come in. So your genetic distance is still quite big, but your geographic distance gets smaller and smaller, and that reduces that R number that I was talking about, that correlation. And what was brilliant about this is that during my PhD, I'd done exactly the same thing, to much less fanfare, it must be said, with pigs, because notice there's no pigs here. Nobody really cares that much about pigs. Some of us do. And what you can see with pigs is that we have 5,500 BC there. We're just notating it a different time frame. You add 2,000 years on that to get to the before present, 7,500 BP. And the same time, all the pigs in Europe at that point, wild boar, were all red. All the yellow ones were from the Near East, and those are the ones that the farmers are bringing in, following this, in this case, this Danubian route up the Danube through Romania and Germany all the way as far west as Paris, which is amazing that the signature from the Near East manages to get all the way there. And that's happening with the farmers as they bring in. And that's the empirical evidence from the ancient DNA. And so then very recently, and this is some stuff that we haven't published yet, these are dogs in Western Europe prior to the arrival of farmers. And what you can see is that everything is yellow. It's on what we call haplotype C. Everything is yellow there. So there are clearly dogs there that are in what we call Mesolithic context, meaning these are hanging out with people who are not engaged in anything to do with farming. They're all hunter-gatherers moving around in a European landscape with dogs, very clearly dogs, but they're all C. And then what happens is as soon as the farming comes in, oh geez, wow. So what's nice is that the green one we call haplotype D, we don't have very many early ones of those, but they're clearly originating in the Near East because we have some evidence of that isn't on this. And they start moving them, again, along that same trajectory, that same pathway. So what we can start to see is this mixing and blending and all of this kind of crazy mushing of these different lineages of dogs, mating and interacting with dogs that were completely separate genomically in a different part of the world as long as 7,500 years ago, and that's just continued. And when you consider what sea travel has done or what people just moving around for wars or for whatever else just in the last 500 to 150 years, imagine how difficult it would be to try and infer the history of the origin of dogs just by looking at the modern population alone. It just seems a little bit crazy. So, to get back to my taxi driver, I think the important point here is that when we ask, where are you from, we have to think about what it is we're really asking. Because the truth is that all of us are from nowhere and from everywhere. And that pertains not just to us, but to our dogs and our cats and our rabbits and everything else. And so if we really want to know where we're from and what that means, we need to think about the nature of that question and what is we hope to learn from that. And what we're trying to do is answer some of the basic questions about what does it even mean to be from somewhere and what are we hoping to get from that idea. And that involves a whole lot of understanding the relationship between humans and dogs and humans and cats and how that relationship might have started and what that means almost on an individual level. And for that, we have to turn to Professor Naomi Sykes.
Lovely, thank you. Wow. Thanks, Gregor, that was amazing. I should start by saying I'm Naomi Sykes. I am from England and have come all the way here. I think it's anyone else from England? Yay! Okay, I have a bond with one person, and to everybody else, I really like dogs. So, England. And it's a real thrill to be here. Thank you so much to Annenberg for flying us over. So I'm going to pick up where Gregor left off. He was talking about the origins of dogs, and what I'm interested in is what happens next, right? How do we get from wolves or wolf-like dogs all the way to this kind of crazy mixture of the animals that we see and can be adopted upstairs? Little ones, big ones, all sorts of different colors. How did we get there? And whilst Greg is interested in looking at big data, you know, you've seen all of these points all over the maps, what I'm interested in is looking at these animals as individuals, right? So a bit like Buddy here. This is an animal which was buried. This tells us a lot about the culture around it, you know, the fact that there is a burial here. But this is an animal that people clearly cared about. And I don't know, when I look at this, this is from a pet cemetery nearby here. When I look at this, my eyes are always drawn to the dates, right? The origins, like Greg has been talking about. People always focus on the origin date or maybe the end point. But have you ever realized that the most important bit on this is this tiny hyphen here that represents the whole life of the animal or the people? And that's the bit that I'm interested in. Not so much the beginnings or the ends, but actually the hyphen. In fact, this whole talk is going to be largely about hyphens because I'm interested in the hyphen between this and this, right? So all about hyphens is my talk. But what are my questions? So my questions are, how can we detect these sorts of human-dog, it's again the hyphen, I'm not interested in humans or dogs, it's the hyphen, the relationship between the two. How can we detect those in the past? Those are the sorts of questions that I'm interested in. And what do those relationships tell us about past cultures? Because if we can understand that relationship, generally we can understand the culture. If you talk to anthropologists, they say if you want to understand people, don't look to what people are saying. People lie, right? Look to what their relationship with animals is. That's where you get the truth. And also, finally, why should we care about any of this stuff? So my question is, why should we care about ancient dogs? What relevance does it have to the present? So the methods that I use are in some ways similar to the things that Gregor does. I provide him with all the data that he then arrogantly says is better than mine. So I'm a zoo archaeologist. I work on animal bones from archaeological sites. I look to see what kinds of animals we have, whether they are dogs, and indeed these ones are, whether they're big dogs or small dogs, whether they were healthy or not. So we've got some pathology here showing issues of disease and disability. I also look to the context in which they're being buried. Like Gregor showed you that beautiful dog who had been buried purposefully, but not all dogs are found like that. Some are just bits and bobs that are scattered around sites, and that tells us a lot about relationships with people. I'm interested in anthropology so that we can examine this stuff in the real world today, but also things like iconography, representations of animals in art, but also in literature. I'm also then interested in a bit of hard science as well. So Gregor has talked about genetics. What I do is look to stable isotopes. This is a different kind of science, but when we were asking the question, where are you from? That is not, to some extent we can answer it using stable isotope analysis, but we can also find out a lot more. So the principle of stable isotope analysis is that you are what you eat, or you are where you eat. And everything that you consume and gets taken into your body tells us about where you're from, which means that we can take samples of hair or tooth or bone and actually tell you about your life history by analyzing the chemistry of your body parts. I'm not going to go into too much detail about this, but what we can do is then map where those signatures, those chemical signatures lie. So it could be, for the purposes of this chart and this talk, is that the more towards the left of this graph, the more your food comes from a terrestrial source. The further over to the right, the more you're eating fish. And the higher up you go on the chart, the higher up the trophic level you are. So if you're vegetarian, you would plot down towards the bottom. If you eat a lot of meat, you would go higher and higher up. So this is the sort of work that I do, and we can find out huge amounts of information about people, about animals, about what they've been eating, and about where. So here's some data that I've brought together. This is 10,000 years worth of human and dog diet. These points represent lots and lots of samples, they're averages. And what we can see starting from 10,000 years ago is that humans are up at the top and dogs here, and that's consistent all the way through time. But what's really cool about this is it shows that people and dogs have always been quite connected, because if we go through time, we can see that from 10,000 years all the way up to about 200 years ago, diet of dogs and diet of peoples has risen and fallen in tandem, which is really cool. It shows that there is a close relationship between people and animals, and dogs in this particular case. So a lot of people think this is really cool, because if they want to understand human diet, and most archaeologists are really interested in humans rather than dogs, they say, oh, well, if we haven't got any human remains, we can analyze the dogs and it will tell us about what people were eating. And that's really the reason why most of these data have been pulled together, is to find out about people. For me, that's not so interesting. I like to look at these data in a different way, because if we look at them here, the distance between the human and animal diet is really revealing. That tells us about how close the relationship between people and dogs was. So 10,000 years ago, when dogs are first being domesticated, everybody would expect that people are coming together and living closely. But if you look at the diet, there's a big difference between human and dog diet in this period. To me, it doesn't look as though the connection between dogs and people was that close at that point. Where things start to get interesting is here, around 2,000 years ago, which is the Roman period for much of Europe. And what we can see here is that the relationship and the distance between human and dog diet is really quite close. This, of course, is based on averages. When I look at particular sites where we've got an Iron Age site, which is before Roman, all the way through to the Roman period and afterwards, the Romans are often sat on top of each other with the dogs. The diet is exactly the same. It's so, so interesting, especially when you start to look at other sources of information as well. So in the Roman period, again, unlike anything that was before or afterwards, we see an absolute explosion of dogs of different sizes. So if we are looking across Europe, before the Romans arrive, we have dog. And it's quite sort of this size. It's not that big, but we don't have lots of small ones. As soon as the Romans come, all of these different sizes start to be represented. We find lap dogs, all sorts of things. And we see this represented in the iconography as well. All of these dog figurines have been recovered from archaeological sites, showing that there are different kinds. This looks like a Westie and a greyhound, all sorts of things in here. And also, the other thing that we see, again, never before in much of Europe, is the burial of dogs. This particular individual was recovered, you can see that it's in a human-sized grave, and it was recovered from a human cemetery. So these dogs are being buried as people, if you like, in this period. So really, really fascinating. And to a certain extent, we could have predicted that if we looked at the historical evidence. So writers such as Columella and Varro, they talk about the different kinds of dogs. And whilst they're not breeds as we would know them today, we do have information that correlates with quite a lot of the historical evidence that there were three types of dog, if you like. You've got your big dogs, which are, people talk about them as being guard dogs or sheep dogs. And they were said to be big and black, like the guys up at the top there that we see represented in quite a lot of iconography. And the authors give us instructions about what you should feed them, which is not meat, right? Because if you are trying to protect your sheep and you start feeding the dogs meat, they might like it and start eating the sheep rather than protecting them. So Columella was saying, don't feed them any meat. Give them beans and water and a bit of milk maybe. You've then got the hunting dogs. Well, of course, you want them to chase after things, so you feed them meat. And then at the other end, you've got pets. And we've got lovely examples here of pet keeping. This one on the left is a tombstone to a dog, Helena. It's written in Latin, and the inscription is about, Helena, this incredible benevolent dog, and so it's represented there. So we know that from the historical text that those pets were real pets, and rather than being fed beans and water, you would give them little treats from the table. So kind of like the sorts of situations that we might have today. So we've got this sort of information from historical texts, but it also is informative then if we want to look at those stable isotopes and find out more about these dogs' diet. So what I did was gather together as many sites where there were large assemblages of dog remains to start investigating all of these things at once. So the diet, the shape, the size, the kind of context in which they're buried. This is one of them. It's the largest assemblage that we've got, and I've got just some of the bones represented here. It's a rural site, and all of these bones were recovered down a well, which is an interesting sort of situation to find. All of these animals quite juvenile, somewhat adults, but all down a well, kind of disarticulated, not really any care going into this. And what this reveals is that the word dog does not really sum up the huge amount of variety of relationships that we have, because these dogs, there's something a bit kind of horrible about it. Again, if you read the texts, dogs were often used in medicine. They were also seen as gods, but if you had a bit of a tummy ache in the Roman period, there wasn't that much medicine. So the dog, you would get a puppy and you would put it on your tummy and stroke it. And everybody knows that stroking a puppy makes you feel better, right? But for the Romans, what they thought happened was that the puppy would draw out the illness into the puppy. So then the puppy had got all the illness. But unfortunately, you then had to break its neck and throw it down a well. So it's not great, right? So different kinds of relationships, and I think that's what we've got going on here, signed sort of sacrifices and that sort of thing. We've got another site where, again, there are lots of dogs down a well, but it's different here. All of these dogs are not commingled. They're all buried as single skeletons down the well, and the whole thing looks different, and I'm going to look at these in more detail in a minute. But then just for additional information, we've got some bones from Fishbourne Roman Palace, which is essentially the Buckingham Palace of the Roman world. Really high status, and we've got some little corgi-like dogs as well. So it's like the Queen's corgis from the Roman world, and also Caister, which is an urban site. So what I did was then do the analysis, all of the stable isotope analyses of these dogs, and these are the results that we've got. I've shown all of the human remains here. This is, again, hundreds and hundreds of samples and all of the dogs here. And what you can see is it just kind of validates that humans and dogs are plotting in roughly the same sort of area. But what I'm interested about is, rather than this sort of cloud of data that's not very interesting, I want to look at these animals as individuals. So, for instance, this guy here, right down at the bottom, this is a poor dog from an urban site, Caister. It's a street dog. It's not getting really very much protein at all, and it was just found as a kind of fragment kicking around the site. By contrast, the one up at the top, that green one, I've never seen a Roman dog have such a high nitrogen value, which suggests that it was eating a huge amount of protein. This dog, buried as a complete skeleton, clearly a pampered pet. But the rest, not so much. So let's have a look then at one site in particular, which is the bulldog dogs, the ones which seemed slightly different, all buried as complete individuals. So when we look at the size of these animals, the two big ones plot down lowest on this scale, which means that their diet contained very little protein by comparison to the others. They're the big dogs, and I think that we're looking at guard dogs here. These are probably guard dogs, sheep dogs. We've submitted the samples to Gregor's lab, And I think that they're going to come back with a coat colour suggesting that they're black, because that's something that Gregor's lab can do. We can start to reconstruct what colour these animals would have been in the archaeological record. These two, though, are both plotting higher up, much more of a high protein diet that these animals are being given, and you can see that they're tiny and wee. So these ones look like those lap dogs that we saw and written about in the texts by the Romans. But what about the health of these individuals then? Well, we can look at this, and that really tiny dog, the one that was highest up, we've got clear evidence that this animal was being looked after. So can you see the two legs? These are both the four legs. This one should not look like this. It's all withered, it's broken. This animal was essentially a three-legged dog. It must have gotten in an accident when it was younger, and it's been hobbling around on three legs. Somebody was probably looking after this dog. It's evidence of care. We can see this. This is not my work. This is work by Michael McKinnon. Another example of a very small dog that was recovered from a site. And you can see that it's got all sorts of pathology. It's an old, old dog with evidence of osteoarthritis. If you look, can you see that it's got no teeth at all on the top of its skull? This dog could not have eaten any food without help. They must have been mushing up food so that it could eat. Again, evidence of care, which is amazing. Lovely to see this in the archaeological record. At the same time, this dog had no teeth, right? Why did it have no teeth? Because it was being fed treats. And if we look here, we've got this massive wad of dental calculus. And the same is true with this individual. Most of its teeth have fallen out, right? So people loved these animals, but they loved them so much that they gave them huge amounts of health problems, which is something that we need to be thinking about. Especially in the Roman period here, this is some more of these bulldog dogs. These are the big ones. Again, huge amounts of tooth loss. You don't see this in the Iron Age, before the Romans, you don't see it afterwards. You see it because these animals were being fed treats. And at the same time, we see it on the humans as well, right? So lots and lots of dental calculus because the Romans weren't brushing their teeth. Now, given that this is the Roman period, the Romans were idiots. They didn't know how to brush their teeth. They didn't brush their dog's teeth. The thing is, being in LA, I see that I've never seen better looking teeth in my life amongst this population. But I was talking to JJ, the vet here, and she's taking a lot of plaque off dogs' teeth. So whilst you take spectacular care of your own teeth, I'm coming from England, you should see our teeth, they're terrible. But the dog's teeth are still not necessarily being brushed, and I think that's an important lesson for us all to learn. You don't be like the Romans, right? Brush your dog's teeth. So there are other unintended consequences of sort of pet keeping. And one of them is that in Britain, as people started to love their dogs so much, they almost created the big bad wolf, and wolves got driven to extinction pretty much, it looks like, in the Roman period as well. So unintended consequences can be that as much as you love your dogs, it often then creates an opposition, and we drive to extinction the things that they descend from. So in Britain, no more wolves, and it looks as though they went extinct in the Roman period. And the same is true with the other pets that are represented here. So I was just wandering around PetSpace and I saw this, that when the Romans invaded Britain, they brought with them rabbits. It looks as though that was probably true. But rabbits, which are now these wonderful, beloved domestic animal, are almost extinct in the wild where they're native. It's worrying to a certain extent. The similar thing is true with cats. So Gregor and I have been working on cats. We've just found out amazing information that shows that yes, indeed, the Romans were introducing domestic cats to Britain, and it devastated the wild cat population, which is again almost threatened to the point of extinction in Britain. So there are unintended consequences behind our love of animals. Again, the Romans were idiots. They didn't know this stuff, but we do. And so we need to think about this as we're going forward with our pet keeping. What consequences are there for our pet keeping? So what have we learned then? Let's bring this to a conclusion. I hope I've shown that, you know, if you're trying to understand relationships and cultures, you can't just use one source of evidence. You need to bring a whole suite of different varieties of evidence together from the sciences and from the arts. And that's something that PetSpace has allowed us to do by bringing together all of these different scholars. We've learned that the Romans probably, of many of the different cultures that I have examined, represent the earliest forms of pet keeping, or certainly in a way that would be familiar to us and we recognize it. That Roman pet keeping culture didn't stay forever. It arrived during the period that the Romans were there, and then it went away. But what we need to remember is that the legacy of that pet keeping did not go away. That's still there and is still resonating with us 2,000 years later. We don't have the wolves, we don't have the cats, we don't have all of those other things. And in fact, in 1963, Zoyner said that, in terms of domestication, there are several stages, but the last stage of domestication ends with the persecution and extinction of the wild ancestors. So it's something that we really do need to be mindful of. As I said, a lot of this stuff, the people didn't know when they were domesticating animals, but we know it. And if we might not be able to do anything about it personally, but there is one thing that we can all do, and that is brush our dog's teeth. So with that, I will pass over to Eric, who's going to finish up the talk. He's your local guy. All right.
Thank you. These are tough acts to follow, let me tell you. Thank you, David. So, first of all, thank you so much for coming out tonight. It's wonderful to celebrate both our love of pets and this deeper understanding of the emerging relationship and the changing relationship we have with domestic animals, and in fact the forces that even lead to domestication. So we've seen sort of this deep dive back into history, but in fact this force of urbanization we see now, which we're going to talk about in a moment, is causing changes to happen incredibly fast. And so when we talk about the emerging relationships of humans and domestic animals, we're compressing these processes from thousands of years to hundreds of years to even a few decades. And joining me through this talk is going to be one of the favorite dogs we've had in our life. This is Tucker, when he was 1 year old. I was an only child and grew up with, I've had about 20 dogs in my life, and sometimes as many as 6 at a time. And so they grew up as best friends to me, and confidants and playmates. And because our lifespans are so different than the lifespan of a dog, you actually go through this process over and over again of this sort of mentoring through puppyhood and adulthood, and finally that profound responsibility that we have of deciding on end-of-life care and end-of-life decision. These are practicing for the difficult decisions we have as adults. And so it's no surprise that I ended up as a behavioral ecologist and studying coyotes and other social vertebrates, because this question of their interaction with us and their interactions with each other are so profound and so interesting. And I really want to thank the PetSpace and the organizations, the National Science Foundation, the Department of Education, and the U.S. Forest Service for supporting our work at the Center for Urban Resilience. And when we think about dogs and we think about the history of our relationship to them, we have to place it in the context that we are now an urban species. So the process of studying this ecology of cities is called urban ecology. And we have a theory that the social and environmental well-being of people living in cities are inextricably linked and in constant flux. So even the word sustainability may not be the right word to use. Resilience is probably a better one, because things are happening so fast. So what does this really mean? It means that resilient, livable cities are only possible if its residents are both healthy and safe. But this includes a rapidly changing relationship with nature, both wild and domestic. And so for many of the people who live in these urban contexts, and that's more than half the world's population, their only contact with nature is their relationship to domestic animals. And this is a complex relationship. The American Veterinary Medical Association, they define this human-animal bond, which here the research team supported by the Annenberg Foundation is really reframing this as a human-animal relationship because it's so complex. But the fundamental definition of this bond is a mutually beneficial and dynamic relationship between people and other animals that is influenced by behaviors that are essential to the well-being of both. So this is a co-evolutionary relationship. This includes, but not limited to, the emotional, psychological, and physical interactions of people, other animals, and their environment. So when we come back from a run, this is Tucker when he's about 5 years old. We're both kind of thirsty from that, and that's something we enjoyed on a daily basis. We would look forward to that. He'd hear the car coming up in the driveway, and he'd be ready to go. And if I was too tired to go, he wouldn't put up with that, so we had to go. So this process of domestication and urbanization are co-linked. So this process of adapting plants and animals for human uses includes food and hunting and companionship, and most recently, the modern metropolis. So fundamentally, what do? Humans produce more humans. And so there are 74 million children and 34 million households in the United States. But the fecundity and reproductive rates of humans globally are dropping like mad, which is a good thing. It means we'll probably peak at about 10 billion people, which is probably sustainable. Given the fact we're living on about 7% of the Earth's surface, that probably will work pretty well. But in the process of reducing our efforts towards children, we have begun to replace many of those efforts with our relationship with animals. So really, for the first time in our history, we have 78 million dogs in 44 million households in the United States. So more people have dogs in more houses than children. And when you think the fundamental process of any organism is to raise more copies of itself, that's how species survive. And yet we're seeing this transformation. And why? Because it is essential to our survival and well-being to connect to nature. And we do so in many ways through our pets. There's also 85 million cats in the United States. That's probably a low estimate because a huge number of cats in the United States are not, they're living affiliated to different degrees with humans. And 70% of people in the United States now live in cities. So this is a profound phenomenon. And so this process of domestication and urbanization, it has such impacts on human behavior, animal behavior, and our relationship as this ecological dominance that we have on the planet. You know, humans move more earth with bulldozers each year than happens naturally through erosion now. It's just extraordinary how fast and massively we change the planet. But this process of domestication is so profound for us because if you look at the other highly social intelligent species like dolphins and chimps, I mean, really smart, live a long time, very complex behavior, they haven't really domesticated other plants and animals. So as a result, they spend a large portion of their time looking for food. They forage all the time. But because we have granaries and we produce excess amounts of food, in the United States only about 4% of the people do the work of the other 96%, we get to spend our times as lawyers and photographers and teachers and researchers because someone else is producing the food and we don't have to spend all day looking for it. That is a profound change because most animals don't make that claim, not for very long anyway. So because of that, our relationship to domestication has created a superorganism. We live so long, we profoundly change what's around us, we create this incredible culture, we have written language, these things that allow us to propel our energies to a greater degree. And so this whole process of demographic transition, the movement into urban areas, becomes a driver, a social driver of change, both in our own lives, in our relationship to pets. So let me give you a candid example, but not a domestic dog example. This is a coyote image taken by one of our team right across the street. Coyotes are becoming an incredibly common urban mesopredator across the United States. As they've moved east from their native lands in the American Southwest, they've doubled in size. It allows them to eat a lot of different food. We had a great conversation over the week about all the different genetic influences that have changed the nature and structure and ecology of coyotes over an incredibly small period of time. But you look at an animal like this, long-nosed sight hunter. This is an animal that should do the predominant amount of its hunting during the day. It's got pretty good vision, stereoscopic, very effective. But here are data from our long-term coyote study that we collaborated with a former graduate student of mine who's now his own mature scientist, Dr. Jonathan Way. And using radiotelemetry studies, we could look at the activity patterns of the coyotes in our study area. And here's the times that they're most active. The shaded areas are nighttime. So in urbanized areas, coyotes completely switch their behavior to hunt and be active at night. Why? because the ones that are active during the day end up in the animal catcher's cage and being euthanized. So you have this intense directional selection to change your behavior. And so here you have an animal with an incredible ecological and genetic legacy who in less than half a century profoundly changes its behavior in order to coexist, in fact, more successfully than ever with humans. There are more coyotes on the planet now than there ever have been. And if we had more time, we'd talk about all the positive ecosystem services that urban coyotes provide. It's a complex story. Here's an example of one of the radio collars that we fit to them that allow us to track their activities. But the relationship of domestic dogs to our own society and to the ecosystems around us are complicated. So the global population of dogs is pretty hard to determine, but probably around 1 billion. And of those, only about a quarter live in a traditional home setting. The others are, to some degree, free-ranging, wild, feral. There's a whole variety of adjectives that don't really fit very well, but they're the ones that we use. We're still trying actually to define that arc of behavior. It's just very, very difficult to do in cats, also hard to do. But free-ranging dogs are complicated in ecosystems. They put a lot of top-down pressure. At least 11 vertebrate extinctions have been sort of tagged to the impacts of dogs, and at least 188 species of vertebrates, according to the IUCN Red List, are directly pressured or impacted negatively by the presence of free-ranging and loose dogs. And those behaviors include predation and competition and disease and disturbance and hybridization. So this is a problem. But I bring this up because when we're talking about an interplay between human culture and behavior and the animals that we live with, there's the opportunity to transform these relationships. And in fact, the emergence in many parts of the world of the use of guardian animals, dogs that are trained to actually protect rare communities of vertebrates against other predators. And so you actually can turn the story around because of the active intervention that we can do as the ecosystem engineers. I mean, one of the things that makes dogs such great companions is they're so malleable. Look at the genetic variation that these folks have been talking about. They're incredibly malleable, at least those that became domestic. Notice wolf populations, sure, they've been persecuted, but they're not well adapted to live close to humans because of the size of the range they need for hunting, their narrow diet width, and so forth. So they're not as compatible. Foxes, so-so. Coyotes, the perfect animal to live in the presence of humans. So this is Tucker's sister, who also spent her life with us and was Tucker's best friend. They always slept in physical contact with one another. They had to be touching each other. So it meant if one was on the bed, both were on the bed. And so some recent studies have shown some incredible social phenomena affiliated with how we connect to dogs. More than 75% of owners say that a dog's health is as important to them as their own. And kind of for good reason, because they realize their own health is linked to the health of their pets, because their pets are so important to them. More than half of those summoned in a survey, questionnaire survey, would choose their own pet if they were on an island as opposed to another human companion. And half are better at remembering the names of their neighbors' pets than their own human neighbors, which of course, we live in a condo complex with lots of dogs. I can't remember anybody's name, but I can remember the dog. And my wife will say, oh yeah, that's this dog, that's that dog. And we know from development that there's an important link between the way people treat animals and the way people treat each other. Because our relationship to animals becomes a practice, an iterative process. Because owning animals is so intimate, the barriers are so easily crossed. And those same barriers with spouses and parents and friends are difficult, partly because though as humans, we're not as malleable. And if you make a mistake, we'll let you know. Your dogs will endlessly forgive you, or at least most of them will. So here's Tucker welcoming the first grandchild into the family. So we know that child development socialization is so central, and as we're having fewer children, the role that this socialization needs are being picked up by our relationship to pets. So having a child grow up with pets and caring for pets promotes a sense of self-esteem. It helps children engage more rapidly in play and also in independence. It provides the opportunity for people to experience the events through the eyes of other than themselves. And there's actually a formal science of doing this. It's actually the basis of some of the early work in ethology called Umwelt, which is understanding the animal's world from its own perspective. In fact, one of the challenges we have is not to treat our dogs as little children, because they're not. They're completely different species. And so their world looks very different than our world. We can promote responsibility, nurturing, loyalty, empathy, sharing, again, these relationships with pets. And in the classroom, especially in special learning conditions, animals motivate students to work well and are fantastic in restoring broken relationships. So the post-mistake recovery associated with the connection to animals. Studies have been done in Australia, found that dog owners ended up paying fewer annual doctor's visits and were less likely to take medication for sleeping problems than non-pet owners. And in China, where the westernization of culture is profoundly changing the way that the Asian cultures view their relationship to pets, dog owners had a higher self-reported fitness and health, exercised more frequently, slept better, saw their doctors less frequently, and took fewer days off from work than comparable non-dog owners. Now, these are very complicated data to gather, and they get commingled with economic capacity, because people who are wealthier tend to have more dogs, and having more resources is a road to more successful life with respect to health outcomes. So these are a little bit different to sort out, but the trends are intriguing. One of the folks who works on our team, part of the group of fellows, Alexandra Horowitz, has been a pioneer in helping us to understand this gap, or this step we have to take to lift ourselves out of our own world, out of our own Umwelt, to better understand the world of domestic dogs so that we can enrich and make better, if you will, our relationship with them. And she sees that it's so critical to move dogs beyond the idea of little humans, engaging the sensory and cognitive world of dogs, this idea of the Umwelt. And through this, we improve the quality of the bond. And both species enter this new ecology, this new co-relationship, this urban landscape where dogs are our connection to nature, and they spend significant portions of their time with us. They add to our quality of life, but at the same time have impacts on the environment, have significant footprints, ecological footprints. Think of the millions of dogs that we have here in Los Angeles, and they don't necessarily play by the same rules that we do with respect to sanitation. And so we have to manage all those aspects. No, these are definitely not trivial. And so urban ecology, with its relationship to animals, sees that there's a false dichotomy between even using the terms human and nature. We are all one system. Ecology is the study not of the things, but of the interactions among the things. And as we investigate the human-animal bond here at Annenberg, we are trying to create a tent that's large enough to invite historians and ecologists and geneticists and ethicists and animal behavior experts and veterinarians and animal care specialists, lawyers, to create a more aware and effective system of engagement. And what we want to do now is open up to your questions so we can better be of service to you. And I'll end with a picture of Tucker in the last couple years of his life. As an old pup, he lived to be 14 years. And we still, you know, your pets, of course, they still live with you. It's just a different relationship, right? It's a spiritual relationship. You still ask the questions. You still are enriched by all the gifts they gave you. And our gift tonight was to have you join us. So thank you so much.
Thank you. Thank you to our panelists. And now if we'll put them in the hot seat, Our volunteers, Nancy and Jerry Ann, will bring the microphone around to you. So if you have a question, please raise your hand. They will come to you and hold the mic for you. And if you could please state your name, if you wish, your organization, and then to which doctor you'd like to address your question to. We may also have some time to address questions from our participants online. Anyone?
Should I hold it or? Okay. John Gregory. I'm a board member of Friends of Banner Wetlands, an environmental group locally here, and also a board member with Heaven on Earth Society for Animals, which is a cat rescue group. Anyway, I'm interested, Dr. Strauss. You had commented, you had pointed out that coyotes had become very nocturnal. Apparently, they learned that it was not wise to be out during the daytime. Do we have any idea how they figured that out and how they're able to communicate that to their offspring?
Well, I would like to have the evolutionary biologist comment on this as well, because in a sense, if you think of evolution as a black box, they don't have to think about it. Those that get it wrong get removed from the system. Those that get it right get the opportunity to breed. So conscious engagement is one of the great questions in animal behavior. How much do you have to know in order to get it right? You don't have to ask your heart to beat on a regular basis. It either does it. We can intervene if it doesn't, but that's not a conscious process. It's an unconscious process. And so we think that animals as sentient and as social as coyotes have to be relatively conscious because they have to map their adversaries and they have to be able to make predictions about who they're going to engage and who they're not going to engage. It's one of the things that drives large brain size in animals is this social engagement. So they can watch things that are happening. They can have sublethal events happen to them and say, oh, I'm not going to do that again. And so that's the whole idea behind things like electric fences and other sublethal controls, because animals can learn from that. So we know that learning takes place, but these kind of selective forces happen at different scales, and they're additive and affect both the behavior, which ultimately affects the reproduction and the transmission of genetic material. So
that's about as good as I've ever heard.
I can talk loud if you like.
You have a good voice.
All right, my name's Jay. I have a dog named Cleveland, and my question's about love. So, do dogs actually love us, or are we just the smell that brings them food? I mean, I know I love my dog. I know I love Cleveland.
yes.
Right, but I read an article in the New York Times about some study about they're putting dogs in MRI machines and scanning their brains to see reactions if they actually do love us when you open the door and it's like, oh my God, you're here. Is that love, or it's like, oh my God, I'm going to get fed?
Well, I am going to force these guys to answer this in a second, but you've actually touched on what's called the hard question in consciousness. The only person in the universe or organism in the universe that loves is you, because you experience it. So the rest of the world we interact with, because of signals that we say to ourselves, I recognize that behavior in myself, and I call that love. And in humans, we have a language that reinforces that. So you ask your spouse, do you love me? I love you. And so you can, but there are, right? It's a negotiated settlement. But we know that there are chemical signals, like oxytocin. And we can measure that, which is a surrogate. That's because love is very complicated. It's a surrogate. And we know that those levels increase as in both you and your dog as you stare into each other's eyes. Especially for canids, because making eye contact is a pretty risky thing. Wolves don't do that because you get punished for that. So getting your dogs to look you in the eye and being comfortable with that is an extraordinary bond. And in fact, in the dogs we've had certain dogs, I think they love us in the context of their Umwelt, but they're just not happy about looking in the eye for very long. And some will.
Ooh. give the microphone to the person who studies animals that have been dead for thousands of years. Well, in my considered opinion, so one thing that I do know from, this was when I was back at university and we were studying this, is a fact that blew my mind, which is that whereas wolves do not know how to smile, the dogs do, yes. Right? And they're really, really smiling. And so they might not, maybe they get our jokes. They might not love us, but they think we're fun. So I don't know. I think that if they're able to express some of our emotions, and we see that they're so close in so many ways, and I think you're right about the MRI scanning. It does seem to be suggesting from a neurological perspective that they are. But as I said, I'm an archaeologist. What do I know? Gregor, what do you know?
I know even less. I'm a geneticist. What is the genetic basis for love? Or you don't have a gene to be capable of doing it or something. But
get like an amazing grant.
Yeah, you could.
Poetry about it must be in there.
I mean, the only thing that I could possibly add to that is something just in my own experience and outside of my academic experience is that, and what I find in my academic career is that I spend a lot of time and making a lot of hay out of blowing up terminology. And even though I studied domestication, I kind of hate the term. And I feel like I create false dichotomies or use dichotomies that I then reveal to be false, but I use them as a scaffold to understand the concepts therein that we're trying to grasp at but don't quite reach. And I feel like love is probably one of those things. I mean, when you ask, does a dog love, what do we even know about what we mean by that ourselves? I mean, do we ourselves choose to love anything? Or is that often thrust upon us by, I mean, everybody probably here has a complicated relationship with those people they appear to love or say that they love. And that will change through time. So what do we mean by that? And I often find when you blow up terminology, you're left kind of going, well, what do we know about anything ever? And then you get the weed out and, it all gets kind of crazy. So it's highly unsatisfying in many ways, but at the same time, I think it's worth exploring that term to think about what we do. And I think that it might not even matter. I mean, what might matter is only if you get the response from your dog that reinforces the love that you have for it. Maybe that's all that really matters at the end of the day. And whether the dog actually loves us or just thinks of us as a food provider, hey, who cares, right? I mean, we're enjoying that relationship.
And Naomi brought up such a great point. And you have to be careful about creating Aesop's fables around evolution and sort of just so stories. But wolves don't need to smile at each other to figure out where they're at. They have primarily their sensory is olfaction, and they'll sniff each other and figure out exactly how they feel about each other. But our dogs will sniff us, but we usually don't do that in return. So we need another pathway. We need another pathway. We're this strange mammal without any hair on our face because we have to send so many signals with all the slight changes in eye position. And when we talk about animals learning human language, and there's been some great ethological studies that debunk this, they don't learn our language per se. They pick up on the subtle cues we don't even think we're giving because that's what we do. Because language requires so much facial expression and things like that. They don't need to know the language. They just see what we did with our face or our hand or the sound, and this is what the expectation was. We have to put earpiece on to start.
Good evening. Thank you for a wonderful presentation. My name's Charles Lozo, and about 2 years ago I started a company called RightRatio.com, and we started to put cannabis extracts together for dogs facing cancer. And I have one question. I couldn't figure out how to get the geneticists involved. But in the archaeological record or otherwise, how far back did veterinary care go? Formalized treatments where either they're developing their own methodology for canines or using human behavior medicine on canines. Is there any evidence in the record that you guys are aware of?
So what we find in the Romans are great, right, because we've got all the texts as well, and the ancient Greeks too. In much the same way as the One Health movement is suggesting that human medicine and animal medicine shouldn't, you need to consider the health of both together. That was kind of the philosophy of the ancient Greeks and the ancient Romans. So the two went hand in hand very often. So things that were good for dog health were good for human health. So often the remedies are the same sorts of things. So that's the earliest probably that we see in terms of actual medicine. But I think, as I was saying, dogs were used as medicine. Yeah, no, lots and lots of animals were, but dogs in particular, we do see them being used. Yeah, that's the thing, right? So it's, as much as the Romans were kind of awful, we haven't moved that far on in some of the things that we do, and there are lessons to be learnt there as well. Yeah.
But the care is, I think what Naomi's talk demonstrated a lot of is what you can see very clearly in the archaeological record is when people are taking care of something that would otherwise, outside of a human relationship, probably not be surviving that long. Sometimes to the detriment of that animal, in the case of losing all of its teeth. But I mean, what's the earliest evidence you have for something that's living much longer than you would expect? I mean, is it pre-Roman, or is there we see this with Neanderthals as well. I mean, there's lots of Neanderthals with broken bones existing for a very long period of time that are clearly being taken care of by other members of that tribe or that family. So, but
dogs are tricky because their teeth, they don't age. It's difficult to work out how old a dog
but
is.
like withered legs, that kind of thing.
Yeah, I mean, you do find that, but again, not so much. Most of the time in the Iron Age, they die.
Right.
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 So
Relatively recently, we'll say.
yeah,
It's a great question.
Hi, I'm Dawn Suskin. I'm the executive director for the community of Playa Vista, and I'm a volunteer here. Thank you guys. It was really an education, an eye-opener. Kind of a random question, I guess. I'm Eric, this is probably more for you because you study animals that are still living. Are you noticing that the lifespan of animals, especially domesticated, are increasing?
So that's a great question about lifespan, because in organisms, lifespan is really important as it maps onto reproductive success. So basically, if there's parental care involved, an animal has to live about three times the length of the development of an offspring, because you got to live long enough to reproduce, then you reproduce and have to live long enough to get that offspring to adulthood. And so the whole notion of lifespan is very interesting, and it's not always related to size. You know, there are small turtles that live to be 200 years old. There are very large animals that live only to be a few years old. So domestic animals, of course, are living longer because, and I'm sorry, I didn't mean, of course, in a pejorative way, but of course meaning because they're affiliated with humans that are living incredibly long periods of time. And that is both a challenge to our social systems and a challenge to the models we have for understanding. But one of the things that we're seeing as populations of wild animals and semi-wild animals become more urbanized, it's an interesting paradox, because urban environments have lots of food, lots of water, and actually surprising amount of habitat. So if you were to take sort of an acre of city and turn it upside down and shake it, you'd actually get, by weight, more critters falling out than you would in non-urbanized areas. That's not very unscientific, but at least you can envision it in your head. My PhD advisor is just walking down, we take his degree away. But the paradox is, the animals aren't living as long, because cities hyper-concentrate disease risk, you have to cross roads. And so the question is, as densities of animals go up in the city, like crow densities are much higher in urban areas than in rural areas, are these actually ecological sources, meaning the animals reproducing and distributing and immigrating out of the city to fill in rural areas, or is it like a sink, like the Roach Motel? They check in, but they don't check out. And the early and incomplete evidence suggests that high densities are related to the fact there's relatively low reproductive success and shorter lifespan. So it makes it even more extraordinary that those animals that cross the threshold to domesticity not only live longer than their wild counterparts in rural nature, but much longer than their wild counterparts in urbanized landscapes. So if you're a domestic animal, your genes are carried in a pretty privileged chalice from generation to generation.
It sort of depends on what domesticate we're talking about,
Yeah.
though, right? So you said it was a question for the modern people, but the study of
In your studies, you can sort of date the actual age of the animal.
That's right, and I'm really interested in looking at life expectancies of humans in relation to life expectancies of animals. And you're right that with a lot of the domestic dogs and cats, for sure, those ones are getting older. But it's pretty startling when you look at these data over 10,000 years, and you see that for a large proportion of the time, the life expectancies of humans and of other animals went up and down in tandem until you get to about 200 years ago, at which point the life expectancies of humans goes through the roof, just huge. And now what are we? We're at like 80 years is our average life expectancy at birth. Whereas the majority of domestic animals, cattle, pigs, sheep, chickens, crikey, just plummets. Like chickens now go from egg to this big in 30 days. When you think about, it'll be his fault. No. So it's purposeful breeding because it's about economics. It's about raising up meat as quickly as possible on as little amount of food as possible so that you can feed a lot of people. And it's incredible, you know, we've been able to feed the world through this incredible selective engineering. But in terms of the life expectancy of these animals, it's very anomalous by comparison. It really is.
If they're food, you want them to live as short a life as possible.
Yeah.
If they're companions, you want to extend the life.
Mm-hmm.
And the only thing I can add to that, which is interesting about domestic dogs in particular, is there's this question about what is life expectancy in certain niches or in certain environments. And there's a study that I'm familiar with that's been published in Russian, but I'm not sure that it's actually been published in an English language journal, where a Russian scientist looked at different ecomorphs, if you will, of dogs in Moscow. And of course, everybody's familiar with the dog that's in the house, the pet that we would associate with. And then there was the dog that lived on the ground floor of the apartment building that was fed by lots of people. Probably had a name, but wasn't necessarily owned by one individual person. On a third level, there's a dog that's even a little bit further distance, kind of generally living near subway stations. So probably doesn't have a name, might get kicked every so often, but is kind of fed off the scraps or just eats the things, but is still relatively close to a human population. And the fourth kind is on the very outskirts of the city and the disused almost suburban elements or industrial places where they're right on the edge of that. And so the question then was, to what degree can a dog, and when you see the survival ages of these dogs when they're dying, it gets lower each step away from a close human contact. So the question is, what the dogs at the very edge of the urban environments they're living shorter periods of time, but are they able to survive as a population without any human interference? And it turns out that, very much like what Eric was describing, that is a sink, that area. So that population is constantly drawing from the urban centers of the dogs of the railway or the subway stations that are then moving out to the edges. And if you cut off that flow, those dogs that whole population will disappear. And that's how reliant dogs have come on to be on human environments and human niches for their sources of protein and everything else that allows them to survive. So that distance, if you can measure that distance, that will give you a very good proxy for how long that dog is expected to survive. And when you remove, there was a great book about 10 years ago called The World Without Us. The thought experiment, or the premise of the entire thing was that what if every human being, all 7.5 billion or whatever it is now, just poof, instant, not through some sort of nuclear cataclysm, but just leave everything else the same, but all humans just gone. And what survives and what doesn't? And are there any dog populations that survive? And I think the vast majority of, not just of dogs, but of the cattle that require all kinds of nutrients and injections and things, whole suites of animals that are very closely associated with us also disappear very quickly. And I would be surprised if that many dogs that are, then you would reverse the table there. So all the dogs that are now super close to us, that rely on us for long periods of time to live as long as they do, without us would just disappear just as quickly. And then you might end up with feral populations like perhaps something like the dingo. But I think the vast majority of dogs on Earth just cease to survive because they have become so dependent on us for their own survival. And that's just kind of an interesting thing to think about.
Hi, I'm Joy Gaston with Rescue Legacy, and I thank you so much for this lecture. I do have a question, and were a lot of these stats just based here in the United States? And then a follow-up to that would be, yes, of course, I would take my dog to the island as opposed to a person, like most of us here. My concerns are, and I'm hoping this is going to happen, that as we lose, having children and offspring, but you know, domestic animals will become part of our family. Other cultures look at dogs and cats, unfortunately, as meat source.
Well, and it's always the danger of packing in a lot of information in a short period of time. So with the exception of the example from China and the example from Australia that were the same author and a little bit of the IUCN data, those are, most of the data come from the United States or from highly westernized, you know, European nations. Because yes, the majority of dogs, if we think of that sample size of 1 billion, the vast majority are not pets, and the vast majority are viewed, their utility or ecosystem service, if you will, is different based on different cultures. And we have a colleague, Andrew Rowan, who's looked at densities of dogs in different parts of the world. And it's really quite interesting because culturally, you know, there are certain parts of the world where dogs are very, very unpopular and you just don't see them. And then other areas where they're really hyper popular. And there's a trend that suggests that rural families have more dogs, but as the population of humans switches to primarily urban dwellings, even though they're having fewer dogs per family, the number of dogs in urban areas exceeds those in rural settings, at least those that are living in under the sort of traditional models of domestic sort of containment. But 3/4 of the world's population of so-called domestic dogs are living in ways that that Gregor described. Our team works out of the Monteverde Field Station in Costa Rica each summer, and we also go into different areas. And there, the affiliation with dogs is predominantly ways that you described. Some are sort of fed, but they tend not to have names, or they're affiliated with a certain village, and they sleep outside, and they get fed at different locations. And so their ecological impact, their cultural impact, their whole suite of ecological characteristics look different. And that's part of the great challenge and opportunity of this community of scientists coming together, because we really need a theory or model or template for doing research that can encompass this incredible range of variation.
And just to add to that, I think that what's important to do is not to place a bit of what I was saying in the talk. We don't want to impose the present upon the past, and I don't just mean that by our understanding of the animals, but our relationships with them as well. I mean, my understanding is that cats, for the entire 10,000 year or longer history with humans, never came into houses until the development of kitty litter, which wasn't until the 1930s. And now you have, it's weird that when you think about, wow, what would you do without kitty litter in a house? You wouldn't have the cat in the house. And yet, especially in the US, where you have people have declawed their cats and now have indoor cats, which never see the outside, but that is a development that is well less than 100 years old. So just because we're not eating cats or eating dogs, those cultures that do, that's probably more the norm, both temporally and geographically. So I hesitate to put too much of a kind of a cultural value on how we interact with the animals when there are 7.5 billion people on Earth ranging across the entire planet who are interacting with animals in a very, very different way. And especially when you consider, as Eric was saying, that 2/3 or 3/4 of all dogs on Earth are effectively pigeons, where they're, in terms of ecosystem services, they're just tolerated. They're just hanging around. It's too much effort to get rid of them, but you don't really spend too much time with them either, and they kind of take care of themselves, but are still dependent upon that human niche. And so I think what we, especially in this part of the world, the way that we interact with dogs is highly abnormal, both in space and in time. And for us to project that against the whole rest of the planet for the 200,000 year history of our species is just a little bit dangerous. And so I think the more aware we are of that, the more empathetic we can be for different ways in which humans and animals interact.
Yeah, I'm just going to add one more thing to that, because coming from England, they say that England is a nation of animal lovers, right? That's one of the things that's said about us. But it's a lie. We don't love animals. We're horrible to animals, right? What we're nice to is dogs and cats. And the more work that we've been doing, the more we realize that actually, so I'm vegetarian, and I generally don't have animals hanging around with me so much. I do. I have cats, but I kind of like them to go off and do cat stuff. I don't need them to live so much with me. And lots of vegetarians who I talk to feel the same. They like animals. They don't necessarily need to live with them. All of my friends who are committed carnivores need to have the dogs and cats, and so that they can say, but I love animals. Look, look, yeah, they're so tasty. So I think that there's an element of that, and it's about this cognitive dissonance,
Yes.
and about
Compensatory behavior.
yes. So I think that's a really fascinating thing to look at as well. So there are some quite good books out there which are saying, why not eat dogs? Right? They're as smart as pigs, and lots of other animals, but yet we somehow have thought it's acceptable to do that. So I was just doing a bit of a switch on that one.
No, and what's also true about that is you love the animals that are in your house, but you don't mind so much that the number of birds that are killed annually by cats is through the roof, right? Like, and so that's such a shame. We see just a giant puff of feathers, but it has nothing to do with me, except for that it is you. It's your cat that going out and then we put bird feeders up, which then the cats are like, oh, thanks, you know. So it's this whole circle of like what we emphasize is what we like and what we're doing good at, and trying to make ourselves feel good about the whole thing, even though, as Naomi was talking about, these unintended consequences are amazing. And so can I steal one of your stories? Sure. So, or do you want to,
What one is it?
the cats and the pelagic fish?
Oh, that's a good story.
Okay, I'm going to let Naomi
you
tell
do
it.
You tell it.
I'm not going to tell it as well as me. So everybody assumes that cats love fish, and that you buy your cats fish. I mean, when you look at cats, they don't swim, right? And they don't get on boats and go out seeing deep sea fish tuna. So why on earth would cats like fish? So it turns out that this comes from a time when people first started harvesting fish, and then they would bring them in, and it was the monks, and then monks were eating the fish on Fridays, and the cats were around. They were like the cats because they were eating the mice, and started feeding the cats the fish, and then noted down that cats like fish. And so then everybody's like, oh, well, cats must like fish. And now, as everybody in this room, if you go to Whole Foods, you're going to get your sustainably sourced tuna or salmon or whatever else. But when you buy your cat food, you don't care where that fish comes from. And what we're doing is we're denuding the seas of a huge amount of a marine resource to feed our pets the cat food, when the cats don't even eat fish. They never have. It doesn't make any sense. So you have all these unintended consequences that we're taking care of these cats and love our cats, while at the same time hating on the sea in a way that is just destroying all vertebrate life in the oceans. So it's just kind of a weird twist of history and everything, and the way that we think about this whole thing. Did I get that mostly right?
You did good.
Okay, thanks.
And we have time for one more question.
These folks on this side, they've been having their hands up for a long time. They're very patient, but getting less so.
Hi, thank you. My name is Linda Manning, and I am a longtime dog lover and a longtime volunteer for Southern California Golden Retriever Rescue. So I enjoyed Tucker. So, and I'm sorry for interrupting before. I just got so excited I didn't think about it. So anyhow, I'm just curious from a rescue point of view. I'm really interested in so many animals in shelters and how people can just throw away their pets, and just it's inconvenient, they're moving or whatever, and so they just throw away the pet. So I'm just curious, your thoughts on that, and is there anything we can do about it that you think, or just from any of your viewpoints, what you would do about that, or how you can understand that better, or whatever. So
I would only make a brief comment. I have a colleague I work closely with, William Lynn, who deals with the ethics of canids, from wolves to dogs, and again, there's a utility function, and in my own comments early on, I said, we've lived with 20 dogs, and only one of them passed away naturally. We woke up in the morning and he was in his curled up in his bed and had passed away. The rest were end-of-life decisions we made as responsible pet owners. And so, those types of decisions you have to make, you sort of distance yourself to the utility. And so, the decision of turning a dog into a center, so maybe it gets a better chance. The idea that ultimately euthanasia reduces animal suffering as a process is one of the descriptions you've seen about reducing the amount of time between birth and when an animal's harvested for meat. Reducing that amount of time is ultimately reduction in suffering. And so these are very complicated things. I'm not in a position as an ecologist to answer that, other than to look at the differing ways in which animal utility is exploited by humans around the world. And all humans are emotional. All humans have an internal set of have an ethical compass that drives their decision. They have a set of sacred beliefs that express themselves in different ways. And so that the behavior that is manifested is so culturally dependent. It's very, very complicated. And so for us, it's a tragedy because we see the loss of opportunity. Others interpret that differently. And as our culture becomes more of a disposable culture, I think this idea of turning things over is something that is pretty central to our identity and reinforced in our culture, our economic culture. Do something good for your economy. Go buy something. Get rid of the old thing. Buy something.
So it's a really interesting question, and the fact that there are lots of animals being turned into shelters means that they're being got from somewhere, right? So those people have to have taken a decision to go out and get an animal. So I think what you need to be doing is nipping the problem in the bud, right? It has to be about education, and that's why this center is so important. I think probably the biggest value of this center is going to be the educational role that it plays. And I think that's where you can start to see differences with all of the education, literature everywhere, and telling people what is involved in actually being a responsible pet owner. I think that's where it's going to be, and I think this place is the one to do it.
And just to add to that on a very small note, again, I'm not in a position as a geneticist to comment on that specifically, but just it's interesting to me that the bumper stickers you see, a dog is not just for Christmas. And in the UK, you can't adopt a rabbit around Easter. Like, it's just, and there's like a 3 or 4 week moratorium in the entire country that prevents people from doing that for exactly the reasons you described, because you do it on a whim. Oh, wouldn't it be cute to have a puppy come out from under the tree? But then, oh geez, you've got a puppy to take care of. So I think that as we recognize what the motivations are for people to acquire a pet, and then as Naomi describes, the education that goes around and description of what the commitment really involves, the entire range of a pet's lifetime will prevent more dogs, cats, and pets, and whatever animals from coming back into shelters. And I think that's a very important role to play.
Thank you so much to our speakers. And really thank you all for the great discussion, the great questions. Thank you also to our online community. We do have more programs such as these coming up. In fact, tomorrow at noon, we have a special guest happening from Canine Companions of Independence. So we will have Melissa Billingsley, who is an RVT, and also a hearing dog raiser here with her dog Hilty. So we welcome you to come back or come down for that. And please continue to come back and visit us here at Wallis Annenberg PetSpace, where you can play, adopt, learn, and grow. Thank you.